Okay, I want to talk to you briefly about something that really is not a very hard thing to do, but for some reason a lot of people tend to sort of get a mental block about it. And you see this beautiful little spider web looking thing I drew. It was working a lot better before I added the whiskers, so to speak. This is supposed to be a polar coordinate grid. Let's see if I have one that's printed out here to show you what it really looks like. But I actually you can put these lines that go through it at different places. I put them at the same place that we put unit circle lines. Like this one has them more frequently, so that they would be like pi over 12, 2 pi over 12, and so on. I put mine at pi over 6, pi over 4, pi over 3, and so on. The ones that we normally memorize with the unit circle. But it's not perfect because I drew it. So I'm just going to stick with it's good enough for right now. And here's the way polar coordinates work. Again, if I have the coordinates, let's go with 3, 2 pi over 3. What that means is I'm going to go to the line going around starting at 0. Same idea as unit circle. I'm starting at 0 and I'm going counterclockwise. I'm going to go around. Here is 2 pi over 3. This angle from 0 to that particular line segment would be 2 pi over 3. Okay, so I'm going to go somewhere along this line, and I could theoretically go all the way down here. That line continues through the origin. But because it's positive, I'm actually going to be working my way from the origin toward that marking. I'm going to be going in the positive direction, 3 units. 1, 2, 3. Each one of these is a circle, basically. So it's saying the radius is 3. That means this small circle has a radius of 1. The next one out has a radius of 2. 1, 2 units. The biggest, not the biggest one, but the almost biggest one, this one right here, this is the circle that has the radius of 3 units. So I'm going to be on that circle in this direction, and that's where this point is. It's 3. It's on the radius circle of radius 3 in the direction of 2 pi over 3. Okay, so here's the thing is that there's actually multiple ways I could describe that same point. And I don't mean changing it to rectangular coordinates. I mean sticking with polar coordinates. There are different ways I could mention that same point. For instance, what if instead of calling this angle 2 pi over 3, I decided to rotate backwards and go in the negative direction? If I'm going clockwise. Well, if you're going clockwise, this is negative pi over 2. This is negative pi. This would actually be negative 4 pi over 3. So that same point could be described as negative 4 pi over 3. There's a lot of different ways to do it. Usually when you're asked to do it, you're asked to give all the ways it can be done between 0 and 2 pi, which basically means, 0 and 2 pi or 0 and negative 2 pi. Between, it's written like this. When theta is between negative 2 pi and positive 2 pi, meaning either one rotation within one rotation positive or within one rotation negative. So we're not going to go, you could theoretically, remember coterminal angles, you could go around 5 times and have a name for that point. We're not doing that. We're going within one positive rotation from 0 or within one negative rotation from 0. Okay, so these are the 2 ways I could name it with a radius of 3. The other way I can name that point is I can say, what if we think of it as going, let's go all the way around in the positive direction to 4 pi over 3. And I'm looking at this line, but I'm going backwards along it. That's actually a negative radius. If you have a negative radius, it means I'm going to start at 0, and instead of going in the direction of the angle that we're talking about, I'm going to go along the exact same line in the opposite direction. I'm going to go 3 away from 4 pi over 3. And I'm sorry, I don't know what I was thinking. That's 5 pi over 3. How many of you have been screaming at your computer? Okay, so I'm going to go away from 5 pi over 3. 1, 2, 3. And that's that spot right there. Okay, so negative 3, 5 pi over 3. So it says if you're looking at this angle from the origin, you're actually going to be sort of, it's like a little guy's looking at this angle, but walking backwards. All right, now this is a positive angle. We could name this angle going the opposite way. Instead of going around in the positive direction, 5 pi over 3, I could go this way, 1 pi over 3, which is negative 1 pi over 3. So basically, here's what you want. You want to end up, if you're naming all the times it can happen between negative 2 pi and positive 2 pi, 2 of them are going to have a positive radius. 2 of them are going to have a negative radius. The 2 that have a positive radius, you're going to name the angle in the positive direction, and you're going to name the exact same angle in the negative direction. Then you go to the ones that have the negative, and you figure out what is the opposite direction of this point. The opposite direction of this point is 5 pi over 3. And that's what you name with the negative radius. The opposite angle, the angle that's basically, if you were to walk backwards going through the origin, you would go to that angle instead. Okay? Another way of thinking of it is the angle that's 180 degrees from 2 pi over 3. Well, we're not in degrees. 180 degrees is the same as pi. And since we're working with thirds, that's the same as 3 pi over 3. So you could say, well, 2 pi over 3 plus 3 pi over 3 is 5 pi over 3. So that's how I know that this is going to be 5 pi over 3. And then to get to the other one, I figure out how far that would go negative. Notice that these two, the positive angle and the negative angle, you can always go from one to the other by either adding or subtracting 2 pi. So to go from one to the other here, you add or subtract 2 pi. And to go from one to the other here, you add or subtract 2 pi. Since we're working in thirds, 2 pi is the same as 6 pi over 3. So 5 pi over 3 minus 6 pi over 3 is negative 1 pi over 3. 2 pi over 3 minus 6 pi over 3 is negative 4 pi over 3. Okay, so let's look at that from the standpoint of just the pattern involved. It's nice to be able to understand how it works on here, but it's also good to understand the patterns involved so that when you look at your answers, basically, you know, yeah, these match that pattern. Let's go with, I'm going to say, negative 1, 3 pi over 2. This is my point, and I'm supposed to name 3 other points, 3 other ways of describing, 3 other ordered pairs that describe the exact same point, also in polar coordinates, in polar coordinate notation. Okay, so I know that 2 out of my 4, if I include this as one of the 4 points, 2 of my 4 are going to have a positive 1, and 2 of my 4 are going to have a negative 1. Okay? 2 of them, your radius is going to be positive. 2 of them, your radius is going to be negative. Because for each of those, there are 2 ways to describe the angle, either rotating positive or negative. Okay? So this particular way, positive rotation. So if I go to the other one that has a negative radius, I have to figure out how could I name this angle with a negative rotational angle. Okay? It's positive. I'm going to have to subtract to get a negative, so I'm going to subtract 2 pi. 2 pi is the same as 4 pi over 2. And I changed it to this fraction because that has a 2 on the bottom. 3 pi over 2 minus 4 pi over 2 is negative 1 pi over 2. So that's how I got that one. Now for these two, the positive, I have to think about what would be going backwards from 3 pi over 2. You can do it visually and realize, well, here's 3 pi over 2 down here. So if I were walking backwards, instead of going this way toward it, if I was going backwards, I would be headed for pi over 2. Or you could add or subtract, depending on how big it is. You got to make sure it stays less than 2 pi. Add or subtract pi. In other words, 3 pi over 2 minus 2 pi over 2, which is just pi, gives me 1 pi over 2. So I know that this is 180 degrees away from that, or pi away from that. So 1 pi over 2 is the same thing. And now this and this, the difference between these are going to be describing the same angle, but one's positive and one's negative. If I have a positive one, I'm going to need to subtract to get the negative one, just like I did over here. And just like I did over here, since I have a 2 on the bottom, I'm going to subtract 4 pi over 2, because that's going all the way around. All the way around is 2 pi, which is the same as this. So this will be negative 3 pi over 2. And those are my 3 different ways to describe the exact same point using polar coordinates.